Thomas, and then wrong screen, switch around.
Is this any better?
That's cool. That's what we want.
Sam, so if you want me to
yeah, I'm going to have to ask you to advance.
Okay, you tell next, and I will do. You know,
yeah, thank you.
Some pushing.
Okay, we'll give it another minute or so to let folks join, and then we'll get started. Okay, looks like we're holding steady. Well, hello and welcome everybody. Thanks for joining. Before I introduce our speakers for this afternoon, just wanted to go over a couple of housekeeping items. The first being that there will be a recording of this webinar that will be shared shortly after, as well as the slides that will be available on YouTube, as well as the Confidential Computing website. And the second is there will be time for Q&A at the end of this presentation. So if you do have questions throughout the presentation, please use the Q&A bubble at the bottom of the screen. The answer to the questions will be done at the end. I'm excited to introduce Thomas and Simon, so I'll pass it over to you both.
Hello. So good morning, good afternoon, good evening, wherever you are in the world. My name is Simon Frost. I'm a software architect in the Architecture and Technology Division at ARM, and here to talk to you about Project Veraison. And I have with me Thomas Fossati, Principal Engineer, also in ARM ATG, who's the tech lead of the project, and is also very active and known to many of you who are CCC active as a member of the TAC and co-chair of the Attestation. What I'm going to do initially is talk about set the stage, talk about the problem set that the Veraison tries to deal with, and drill down into some of the background of that. So Thomas, if you could advance the slide, please. So to set the scene, this quote is from CCC themselves. So the confidential protects data in use by performing computation in a hardware trusted team. So from this, in order to protect, to say words like protect and things like that, it's really important that anyone who's using or relying on a confidential computing environment must be able to establish that they really are talking to a hardware-based team. And this means that they want to know that both the hardware is capable of it and it's an appropriate instance of that hardware, and also that any software, if we're talking about a service that's been placed into that team that underpins their, if you like, application or business logic is correct. And the means we use to establish that trustworthiness is attestation. I'm taking a big jump of faith that the audience here, if you've shown up for this, probably should understands the concept of attestation. If not, I apologize. There are lots of excellent materials within CCC. I hope that some of it will be obvious, if not, but we're not going to go into the details of attestation. But attestation, as regards interaction with the device, will produce a report in terms of we supply that to the user, the relying party. But being able to report that, produce that report alone is not sufficient. And in order to really establish trustworthiness, the report must be verified to prove the claims, the evidence within it. Advanced slide, please. And when you're verifying a report like that, there's some common operations that apply to most of the technologies that underpin this stuff. So you need to deserialize from the blob that is the received over the wire, and syntax check the attestation report that corresponds to a certain data model. Reports will need to be cryptographically signed to make sure they've not been tampered with in transit. And to do that, you need to know the relevant signer, the trust anchor, which is responsible for that. Most reports, or many reports, include measurements that respect the state of the platform or the components that have been loaded into the platform, and those need to be matched to some reference values. Those reference values, in turn, must be drawn from the supply chain, from the manufacturers that will put this together, and that would involve multiple actors. These also need to be kept up to date, so it's not just an initial response that reflects how a device is shipped, but also it's to reflect how the device may have been updated, or any change in status that has been that is now subsequently known about a component, for example, something like a CVE register or something like that. When you're trying to connect to the supply chain, you may have many parties. You may have to establish a business relationship and a trust relationship, as well as just that ability to transfer the data across. And then once you trust the individual claims, there may be the necessary to apply semantic relationships between claims, depending on your individual trust model. For example, you may only want to trust certain hardware and firmware or software combinations. And all of this process needs to be trustworthy itself. The supply chain, the verifier acts as sort of like a transient level of trust through to the supply chain. Next slide, please. This picture is drawn from the IETF Remote Attestation, or RATS, working group. They have done an architecture document for attestation. And this shows the role of the verifier in attestation, and its relationship to the multiple other roles and the interfaces and the data flows that respond. And it shows that from our point of view, or the important point of view, is that the key role that it needs to play. I'm going to delve down into a couple of these. I'm still scene setting on this. Could you hit advance, please, Thomas? So the first piece I'm going to talk about is a little bit about the supply chain, and then a little bit about the variants you might see in the test bed. Advance, please. So this is a drilling down into that top left-hand corner of that diagram of these various actors. This is an idealized view, but it tries to capture some of the things I've been talking about. So when you are the details you need to determine the makeup of the device and whether that is a secure thing or not, requires information from multiple parties, potentially, and also multiple parts of a device's life cycle. So things that can only be known at manufacturing time, so things like secret provisioning, and then things that will be augmented as the underlying architectural technology is augmented by things that make up a device, and those things may or may not affect the TCB and into manufacturing. And then after a device is in the market, it will be updated. And these days we are lucky enough that most devices can stay up to date and solve our problems. And then even after a device has been disposed of, that may be an event you want to capture. So next slide, please. Now, if we map the use of this into attestation, you can see that events in all of these places are needed by an attestation verification service. And so not only do you have things which are related to your supply chain, but potentially you may have other parties that get involved as well. You may have things like if you have a certification service, like for example the PSA certified system, there may be external information which will affect the trustworthiness stance, and that can again all flow into the verification service. Next slide, please. Even if you are just in-house, there are also attestation scopes which are entirely localized. So there are various use cases which are enterprise focused, where an enterprise admin is actually, if you like, the main supply chain actor, and they still need to supply this similar level of information based on their own catalog, but also based on their own cadence of updates based on probing golden devices and then distributing that into a local verification scope. Next slide, please. And again, here we're back to the rapid view of the world. This is away from the supply chain. This is talking about some variation you see in a heterogeneous environment. If you are in an arbitrary deployment, if you have multiple device contexts, you may have different attestation contexts to cope with. You may have different types of results, of attestation results you want in order to be consumed for different scopes of relying parties. And ideally, you need a single point of contact for all of that. Next slide, please. So with all the variants, I've been trying to introduce an element of chaos, or suggest a level of chaos. If you have to introduce custom solutions or different solutions for all of the different deployments, the different connections into the supply chain, different device scopes and things like that, if there's custom code and custom logic for all of those pieces, then quality is inevitably going to vary. And this may affect the trustworthiness and the overall reliability you could place on a confidential compute input in that. It also means that building a verifier is a barrier to entry for a deployment of a new confidential system. And this is where Veraison comes in. Veraison is the word we used for the project because we can squeeze verification of attestation into the project name. And the process, the idea behind Veraison is not that we would build a verifier that works for everything. Because of, I hope I've maybe been able to suggest that the complexity involved would make that too complicated. Instead, Veraison builds software components that can be used to build attestation verification service. It's an open source project, fully open governance. The initial contributions are being made by ARM, but this is not just an ARM thing. The intent is to have an industry-wide scope. Next slide, please. So what we're trying to support here is, we acknowledge the role of verification in completing the circle of trustworthiness and attestation. And we think verification needs to be, commoditized. To commodify it is to make it, fixable, flexible. I'll probably say flexible quite a lot during this, and open and extensible. And it's a building block that people can use to build this aim. Next slide, please. The use cases are, again, is that the word flexible, is intended to work for many different systems. There's not just one use case. It's not just going to be one particular cloud, or not to be one particularly premise-based system, a piece of that. It's intended, these are components which are flexibly reusable. You can have multiple attestation formats at the same time, or just dedicate to an individual attestation format. You can have your data sources dedicated or multiple and segregated on this stuff like that. And I've talked about services as being the main model, but there is also the potential for, or it's acknowledged the fact that if you're outside the normal pattern, that you could deploy these software components, because the software components are on a local basis, and this is especially true if you are able to run these in an isolated execution environment such as TrustZone, or indeed a confidential compute environment themselves. Next slide. And now I'm going to pass over to Thomas to talk more about the architecture within Veraison.
Cool, thank you. Can you hear me?
Yes, loud and clear.
So fantastic. So Simon has explained what the high-level goals are, and now we can have a look at how we're designing the software architecture to meet in fact these goals of flexibility, of composability, of reuse, etc. So if you look at the big picture, Veraison has two main deliverable categories. On one side, we have the attestation data formats, i.e. the external interfaces. So formats for evidence, for attestation results, for endorsements, for ref values, for trust anchor provision and whatnot. And on the other side, you're going to have the verifier pipeline proper, which itself breaks into two separable pieces. One is the provisioning side of endorsement of ref values and trust anchors, and the other one is the verification of evidence. Let's start with the attestation data format. So, and let's have a look at this through the lens of the REST architecture picture, which is very nice because it shows what kind of conceptual messages we have instantiated so far. And so on the ref values and endorsement side, we are building on Corim, which includes commits and cost suites and is wrapped in a nice cozy sign-one signature. On the evidence side, we have, at the moment, we have EAT, we have PSA, which is itself an EAT profile, and we have DICE. And there is some currently, there's a current work we're doing to integrate TPMS attest too, but that's not yet there, so I didn't put it into the picture. But we're working on that. And on the attestation results side, we are building on the trust vector format, which is a work in progress as well. And regarding the trust vector, I'd like to open a quick parenthesis because it's a format that we have embraced quite recently, and it has had some repercussions on the overall architecture. So in fact, we had to shift a few boxes around. We had to reorganize some of the internal interfaces in order to accommodate that. And interestingly, it's made emerge another architectural block that we had not envisaged initially. So it's been quite an interesting journey trying to integrate that. But so what is this trust vector? This is a format to represent attestation results in a normalized way. It basically creates a sort of checklist of bucket list of typical micro appraisals, right? That you want to have always, like, you know, a tester identity, both from a cryptographic perspective and on a non-cryptographic perspective. The TCBA integrity along, you know, the usual axis of code configuration and file system and other stuff. I don't remember exactly. So yeah, some other stuff associated with the high-level features of the TE, like confidentiality. So, but you know, this is a significant step in the standardization of the relationships between the relying parties on one side and the verifiers on the other. And I think it's great news for the attestation ecosystem as a whole. You know, spoilers, it is going to be adopted in the ATF soon. It's under call for adoption as we speak. Many people have raised their hand to see this is great stuff and needs to progress. And from the point of view of Veraison, what we're going to do is we're going to be early adopter of the format and provide an instantiation of the information model based on EAT and JSON, so JOT kind of stuff. So although this is creating quite some churn in the Veraison code base at the moment, which is, you know, a bit wobbly, the main branch is a bit wobbly at the moment. But we think that there are very positive long-term repercussions of having it in the architecture as a core asset that offset the kind of effort and rework that we are doing at the moment. So this is an interesting bit. So going back to the attestation data formats, yeah, okay. So this is the snapshot as of today. So if you go to the Veraison organization on GitHub, you're gonna see all the repositories that I'm listing here, which are in fact Golang packages themselves. So on the evidence formats, we have 3 packages: EAT, Veraison PSA token, and Veraison dice. For ref values and endorsements, including trust anchors, we have another 3 packages, which are Veraison Suite, Corim Commit, and Corim Corim. And we also have some extra package for crypto support for places where the Go standard library, doesn't reach at the moment, especially for regarding the Cozy implementation. So we had to fork Mozilla services Go Cozy in order to have a place where we could implement the sign one signature format, which wasn't there at the moment. And with the idea, of course, of upstreaming it when it's time to do so, which should be soon. But one thing that this picture sort of hides in a way is, and something that I would like to spend some time on, is the fact that, these are not all the same thing. So some interfaces like Suite and Core Suite existed. So we had just to code against the spec, right? In the case of Core Suite, we intercepted the document when it was in working group plus core, if I remember correctly, and we had to, we just trimmed a few types and suggested a couple of things, but this was very minor work that we did there. We could just take the document and code the library. Some interfaces like Heat and to a smaller extent Dice are still moving targets. And for Dice in particular, there's a question of which dialect of Dice we want to implement, right? There's the old stuff, the right stuff, the TCG Dice, there's the Google Open Dice. So depending on the deployment, we cannot make our choices here, I think. Anyway, other interfaces are completely under our control, like the PSA token, because we own the spec, we own the code. But there are a few of these. This is the interesting point here that I want to highlight. Some interfaces didn't exist, and so we had to go off and contribute to their creation, right? And Corim Commit is exactly that thing, and to a smaller extent, the trust vector, which was already there because Eric had, had already prepared nearly the whole picture, but still we're working together on the finer detail of the spec. So this is just to say that we are a small team, and it's not just the software that we need to produce in order to make this work. So sometimes we have to, this is sort of uncharted territory in some of its places. And so we have, sometimes we need to literally fill in the blanks in the pictures, and this takes time. So, so if we are progressing a bit slowly on certain areas, it's because we need to define the landscape first. Okay, I finished with the data formats. I'm going to talk about the verifier pipelines. As I said, this breaks into 2 separate pieces. You have the provisioning pipeline, for which the supply chain can pump in endorsements and ref values and trust anchors, and in parallel with that, you have the verification pipeline, which is the thing that is responsible for appraising evidence that comes from the attester and producing the attestation results for the relying party. And these 2 bits, which are mostly orthogonal, are joined together by a component that is called the endorsement store, which acts as the sort of logical glue between the 2 guys there. The thing is a bit of a misnomer because it's not a static store. It's got brains and is responsible for quite a lot of things in the architecture. And in particular, depending on who's calling the endorsement store functionality, it will implement, different bits. It's a sort of Janus. So on the provisioning side, it has to store, to archive the information provided by supply chain about the devices, their identities, the expected shape of their TCBs, etc. And on the verification side, it offers the lookup matching logics for correlating the evidence to the relevant endorsed and ref values, as well as the the joint to the trust anchor store, because for verification of the cryptographic evidence. Okay, so looking at the provisioning pipeline in particular, what is the goal? What is the goal here? The goal is that we want the authorized supply chain actor to give us the material that describes the testing and target environment, so that we can use that in the verification process for evidence that has been produced by that specific attestation environment about that specific target environment. So looking at the picture, there's some sort of core design principle that emerges that we use throughout the architecture here, and it surfaces for the first time in this picture. So I wanted to spend some time here, analyzing a bit the ideas, and the idea is that there is an horizontal axis here, which is the skeleton pipeline that sort of breaks, I'm going to say, it drives data through a common set of ordered stages in order to achieve a goal, right? And each of the stages represent a logically separable manipulation on the data itself. So each stage has its own responsibility, and there are well-defined handover interfaces between the stages where the processing context is passed across. At the same time, so we have we compose the horizontal direction of processing with some vertical axis here. Because we need to absorb the diversity of the outside world, which is potentially unbound, right? We don't know how many formats will exist tomorrow, and that's the thing. So we want to be flexible. We have a core requirement about flexibility of the architecture, so we need to take care of the possibility that the formats evolve. Some of them will be obsolete in the future, some of them will come, and in general we cannot assume which one of them will be present at any point in time. So we need a way to exactly plug in the specific formats as needed. Okay, and the principle here is to encapsulate that specific logic into these pluggable components, the colorful things that you can see there, that will be called at precise points in the processing chain. And these guys will be responsible for resolving any attestation format specific aspects and sort of, normalize the thing normalize the data in a way that the blue line, the blue components can understand and manipulate. Okay. And as an implementation detail, maybe interesting for some of you, at this point in time, these pluggable components are implemented as HashiCorp plugins. And this is an interesting bit because it's quite different from the native Golang plugin model, because the plugin runs in a separate process and communicates via IPC. Specifically, you have a stream socket, and on top of that, you have gRPC layer. And you have the input and output from the plugin that are represented at protobuf serializations. And so, and this code, we know that it expands the TCB and therefore needs to be handled with care, with absolute care. We know that, but for the time being, we have sort of punted those aspects, and because anyway, there are other things that are security sensitive and will be, we think, deployment specific. And so they could be absorbed by the specific deployment. But a couple of nice security features that can help here is, for example, the fact that the plugin doesn't have access to the main process memory. So they're two completely separate things from a memory management perspective. And also, being a separate process, if the plugin crashes, is not a catastrophe. So the blast radius of a failure in the plugin is not hitting the main pipeline. And the third feature of the HashiCorp plugin that is interesting from a security perspective is the fact that you could, on top of this stream socket, put a mutually authenticated TLS channel for communication between the main process and the plugin. And this is something that we have not yet explored, but could be interesting in a situation where the fat model is such that you need also to cover for the channel, for the communication channel between the two processing entities. And another nice property here, which is orthogonal to the security aspects, but it's interesting for other reasons, is the fact that the plugin can be written in any language. You just need some gRPC scaffolding on top and bottom, and the rest is all business logic. And once you compile that thing, for the target platform, you just drop the executable and you let the plugin host handle the lifecycle events, load, init, term, whatever. So this is quite cool because it allows, third parties to contribute their code, in ways that are not necessarily, not necessarily open source. You could just drop an executable and be done with it. But anyway, I'm a bit off on a tangent, so I need to go further. And now, okay, yeah, and talk about the verification pipeline. Here, what we do is, the purpose of the pipeline is that we take evidence from an attester and we need to appraise that and to produce an attestation result for the relying party. Again, you can see the distinct shape of the pipeline here, the blue things, although this is a bit more convoluted because the verification is slightly more complex than provisioning. So starting from the left, evidence is supplied via the Veraison REST API, which is a well-defined REST interface, which we'll talk a bit about later on, that in this case handles a challenge response session. So the data comes in, and depending on the MIME type of the submission, the decoding stage will dispatch to the right plugin decoder. And once that is successfully done, and so from the bespoke format, you have a normalized set of claims, and maybe you have extracted a key ID, then we can go and verify any cryptographic property, which is done by the crypto checks stage. And this will call the endorsement store because that's where the trust anchors are stashed. And the endorsement store will in turn call the right verification plugin, right? So there's a pair attestation format logics that is plugged into the core pipeline there. And if that is successful, then we proceed to the endorsement query stage. Okay. So this is the epi path that I'm trying to describe, but at any point in time, you can short circuit the pipeline processing and just go to the last stage and sign it and push out. And in fact, it's maybe worth noting that the processing context that is passed across the stages contains the attestation results from the very beginning. Right? Initially, it's empty, and that thing gets incrementally populated as we walk through the stages. Okay. So resuming processing, we are now at the endorsement query stage, which is where, again, we call out into the endorsement store and ask to match evidence against any applicable endorsement. And again, the right plugin is called, which does the legwork and updates the attestation result with its finding. At this point in time, we have achieved a stage where we have some sort of baseline appraisal. Okay. And now what we do is we pass the trust vector that is being populated by this initial appraisal along with evidence to the custom appraisal policy stage. And this stage, we look into the policy store and see if there's a custom policy that applies to evidence. And if so, it will run it. Otherwise, we'll just keep to the last bit, which is the signing stage. We do the policy engine using OPA, the Open Policy Agent, which means we expect the policy being written in Rego, which is a Prolog-like query language with the familiar with the fact and rules. I don't know if you're familiar with that, but it's quite. If you've done Prolog, it's quite that thing. But we won't go deeper than that. If you're interested, just Google OPA Rego and you'll find a lot of information about this. Anyway, the important thing to keep in mind here is that the appraisal policy can override any of the result computed by the endorsement query stage. So anything that is in the baseline appraisal could be potentially overridden by the custom. So policy has really the last word here on what the attestation result is. And so this provides a further level of customization of the deployment. And now we're really done, or nearly, okay? So the last step is signing the attestation results and maybe embedding information about the signer, which is the Veraison deployment. So the version of the software, some other stuff, maybe the policy. Maybe a policy identifier in order for the relying party to understand exactly what was the domain of interpretation that was used during the appraisal policy, and maybe even for an audit trail that happens later on to understand why the result looked like that. Okay, I'm done with that. I want to have a brief look at the Veraison REST API. Okay, as we've already highlighted when we were discussing the processing pipeline, both pipelines begin with an API front end, which is where we expose the REST API endpoints. And we have two of them, of course, one for the supply chain and the other one for the verification, right? The supply chain will pass in endorsements, and on the verification side, we're going to have either the attester or the relying party, depending on the topological model that's used, that will submit evidence for verification. Well, the first one is, the provisioning is quite simple. You just post some data and monitor what happens to that data. The other one, the verification, is slightly more complicated because it needs to model a session with parameters supplied by the server, which is the challenger, whereas the API is initiated by the client, right? So you have a slight complication because of the roles mismatch. You also have a bit more states there, and so that complicates slightly more the API, but not too much. These two APIs, obviously, on the server side, have an implementation in Veraison via the provisioning and verification HTTP front ends, whereas the client side is in a separate Veraison API client package, which also has a command line interface, if I remember correctly. And the interesting thing to note here is that, unlike other base data formats that we have discussed beforehand, EAT, DICE, etc., we have no real interest in standardizing the REST API, right? We build this on top of at least a part of it, on top of the interaction models, which is another RAS document, which describes the various interaction patterns between the attesters and verifiers. But we don't think it's important to go through an SDO in order to have this standardized. We just what we have we think is sufficient, and what we have is basically an open API spec file for both, and then we have reference code, of course, that implements against the open API spec. And we reckon this should be enough, right? Of course, we'll need to register a few MIME types for this, but this is a very lightweight process compared to going through an SDO to obtain the code points. We can handle that directly with IANA without any fuss. So what time is it? 37. Maybe I could skip over this. These will be available through this. The slide deck will be available. So if you want to take a look at it, it is there. So I will go through the details here and land on the last slide for me, which is this one. Tooling for the supply chain. So as we already said, we have worked on producing the quorum and commit standards in TCG, which, by the way, just yesterday have been approved. So some good news. And we have worked on the implementation in terms of library code, but and this is what we've done for other data formats as well, like EAT, etc. But in this case, we did a bit of extra work towards the supply chain in order to give them some decent tooling that they could use in the factory, possibly in an automated way to package endorsement into signed quorums and then pass those things around, ship to the verifier, etc. And the idea being that, the idea that motivates this sort of projection outside the, I would say, the natural confines of the verifier is that we think we need to lower the barrier to entry for supply chain actors. And at the same time, we want to try to defragment the ecosystem. which is at the moment, very, very bespoke, very, very fragmented. But because their input is so important into the verification process, we need really to smooth the path and give them, a usable and flexible data format. And that we've done with Quorum, which, has proved to be very, very flexible. You can do dice natively, you can do EAT stuff like PSA, which we need just, we need to profile a bit the thing, but that's it. We have looked very recently at a TPM, how to supply TPM PCRs into that, and that work flawlessly. So this is really flexible and works. But at the same time, we need to give them ways to make use of the format in a simple way. And so this co-CLI is born, or co-clear, or whatever you want to call it, and which is a command line interface that one could use to manipulate commit and quorums and score widths as well, which is become part of these, sort of Veraison extra deliverables, and we're pretty happy with that. Okay, and with this 40 minutes, I can hand it over to Simon. Thank you.
Thank you. So I think hopefully you got an idea of how the components go together, and these are the components which is the output of Veraison. Now, obviously these things are no use standalone. They have a series of tests to do standalone, but they're only of use in how they're turned into a service. So it's important to understand that the components are built over an underlying platform service. So if you want to take these components, you consider your platform services. What is the relevant storage? What are the abstractions and pieces of that? The project will be producing references for standalone container-based systems and a hyperscaler of choice would reference and things like that. These aren't intended to be production quality, but they're meant to be things. They're hopefully things that could be picked up and extended rather than just being throwaway items for things like that. There will also be, representatively for what it takes to build a service. There will be, basic implementations and integrations into the components for things like, audit trail or multi-tenancy isolation. So the concepts required to support those things will be embodied in code. And the intention is, we keep using the word extensible and flexible, is that we can support pieces of this. So the initial design intent has been to work with multiple formats and multiple use cases. At least all of the design work has been conceptually tested against multiple instantiations and multiple deployments. And the scaling aspects, all of the work, the way the components work, is intended to be managed discreetly, so that these pieces of work will component will operate discreetly, and then those components will be able to produce counters or instrumentation for their usage, which can then integrate into an external scaling, which will of course be very different for different deployments need for that. Next slide, please.
Oops.
Oh. And just the final slide, just to wrap up what the status is. The project is active on GitHub. As Thomas has pointed out, there's a wide set of repos for different pieces. The project runs completely with open governance, and everything is discussed in public as far as we can make it. There are weekly public meetings where the core team meets, and other contributors are starting to come along, we're delighted to say. We have active collaboration with standards bodies. We think embracing standards is really important here, because that whole interest in that whole maximum integration with other viewpoints on this, and lowering bodies to entry, barriers to entry for this stuff. The initial design work is complete. We have tested it and we discovered that we needed to reiterate. There will, of course, be many more details to manage on, but the intent is to produce work on the reference implementations as a set of demo stones. These will be captured in the public meetings as to what is meant to be working to core this thing and support for different formats, different use cases, and things like that. There is a long list of potential features and capabilities for which we welcome contributions, and contributions both in terms of review of the design of the use case, just the general ethos of the project, and of where it might go, what will be most useful in terms of interaction for that sort of thing, and of course contributions and collaborations in terms of implementations. I think that's all we had, and we would welcome questions. I've answered a couple on the chat. I think we may have some more. I think the only one outstanding one is how is the sign process in the validation pipeline protected, especially the private key that somehow has to be used? I could just punt this and say that this is it is to a certain extent, this is an implementation problem. It's not necessarily practical to understand all this, but we do understand that is a real key answer. But so the project won't embody the whole ceremony or piece for that, but there will. We have discussed being able to do integration with hosting service, key hosting services, or key protection services for reference implementations, and there will be work on threat models and on a security document which will help people understand this problem. Are there any other questions, or have I missed any in this list? Do please just chip in. Oh, hang on, another one. Mohammed. You mentioned most and not all reports contain measurements. I think measurement is a key component of attestation. You justify your claim by giving a practical scenario where a report without measurements will be useful. I think what I was referring to there is sometimes the measurements are rolled up into a TCB version, where they are not necessarily explicitly measurements in the attestation report, but what you'll find is just if you like, a security version or an epoch number. That was my difference, but I agree with you that most particularly valuable reports do contain measurements. I hope that answers the question.
Marcus raises hand.
Yeah, my question is, so traditional TCG attestation always used to include a nonce, a source of freshness, which made the attestation service stateful, which is kind of hard to do, a stateful attestation service if it's going to be, say, auto-scaled. So I actually have a couple of questions, but my first question is, have you given any thought, is freshness even necessary for trusted execution environments?
Well, I would say a lot of cases, yes. What freshness means can vary with deployment. I know there is a lot of things where the freshness should be really related to the state of your attestation protocol. In other cases, it may have a relationship with the verifier, and that you may need the concept of smart challenges where they are reused. In other cases, there may be deployments which it's sufficient to use things like time period based freshness. It depends a lot on the answer. We are not limited to one model, though we have contemplated adding smart challenges as a feature.
Yeah, I just haven't seen anything in your architecture that maintains state. That would be required in order to have, or honor nonces.
Well, I haven't gone through the slides that define the challenge response thing, but here is. the answer maybe to your question. And in fact, we keep state, right? So you create a new session, and that creates the states associated with that. So,
I see.
okay.
Okay.
And then the nonce is that what you include in the thing. And then just to elaborate a bit on the thing, on the so-called smart nonces that Simon was suggesting, together with what you said about the scaling property of something that is stateful per definition. There are things like handle epoch IDs that could be used here with the same interface as the nonce, which can be reused on for short time windows across a population of actors in some situations. So that might be a way to work around the state problem that you have in case you have massive floods of verification requests at the same time.
I think we've also discussed who takes the role of proving the nonce. And it may be sufficient that you just replay the embedded nonce in the attestation report, and it's up to the relying party to know their own context. Or this is potentially something that can go into the policy, so the verifier can take a hand in that role.
Correct. Yeah, you could offload the state handling to the relying party if you wanted to. In fact, we have
not always. Not always.
It's a choice.
It's a choice. I am not saying always, but it's possible to do that in some specific cases. But if you don't, then there are other ways. And I think the epoch IDs, if you take a look at the RAS architecture, if you're familiar with that, but section 9, I think, has all the freshness discussion about. And the epoch ID is one of the possibilities. And if you're interested, we can, I can forward you some of the initial prototyping I did on that. But just get in contact with me, and I will send it over.
Okay, thank you.
Cheers.
Do we have any other questions?
Actually, I do have one more.
Go for it.
So attestation is in your TCB, and pretty much you have to, either completely trust the provider of your attestation service, which again, if we're going to have a confidential cloud, that is problematic. So I know Microsoft attestation service, which I had a hand in building, is actually uses enclaves, but that creates the turtles all the way down problem, both in terms of needing confidential consensus between, again, the cloud services need to auto scale, and in terms of just figuring out how to establish trust, in the confidential attestation service itself. I'm just wondering what kind of considerations, and this is again, any architecture, like the architecture you built can work in trust execution environments. That's not the problem. Absolutely. But I'm more curious as to the broader context of how do we handle the operation and the governance of confidential cloud services, especially the ones like attestation service is almost self-referential.
No, I agree. It is a turtles problem. To a certain extent, at the end of the day, it comes down to what the relying party's threat model is and what they're prepared to accept. And there is actually a business. I mean, and it's a scary thing, but there is a sort of a certain level of business relationship in this. It's like what proof do I need from a level of trust and interface which represents a verification services, and what am I saying when I am saying I'm sitting up here as a verification service? Is like, what extra proof do I need beyond saying I have a certain reputation or a certain SLA or something like that? I think that does come into it in the end, because it is a choice that any individual relying party has before selecting a verifier. Now, it may be that they have to choose a verifier because there is only one available for a certain ecosystem, but then they also have to consider what is then that relationship of that relying party with its supply chain. And that gets even more complicated when you have something like confidential compute, where the environment may have to sort of have a plausible deniability saying whether it can be at arm's length or not from these things.
But
Yeah, it's a problem.
Can add a bit here. Maybe what the browsers have, how the browsers have resolved the problem of anchoring trust on CAs for HTTPS traffic. That might be a way to handle this, right?
Yeah.
So having right parties with trust store that includes anchors for the verifiers they trust.
It's just my bigger problem is not that, like, you can establish a secure system, you can attest to the attestation service code, you can actually trust it, you can open source, you can do all sorts of things. The problem that you're going to have, and again, it hints at a broader problem with confidential compute and confidential service governance, is that a code update can be rolled out at any time. And unless you open source absolutely everything and provide a complete transparency, which I don't think can always happen, you're going to have a problem where a malicious or accidental introduction of a bug can basically bring the whole edifice down. Yeah, and attestation services are way more, because they are at the very root of trust here.
Yeah.
So anyway, I don't expect to arrive at a solution here. It's just something I just wanted to know if you know of any prior art or any any wisdom.
No, I think it's an active discussion point, and it's for the CCC community as well as that. And I mean, our thesis, if you like, is that by trying to bring some commonality and commoditization to this part of it with open source code, is that we can assist with that process, but I don't think we can solve it independently.
Yeah. Okay. Thank you.
Cool. Thank you. Very nice questions, in fact.
Yeah, no, we'd love to debate that further. Okay, I think we're nearly at the top of the hour, unless there's any other questions. We may be done.
Okay, well, thank you, Thomas, and thank you, Simon, and thank you, everybody, for joining today. Like I mentioned earlier, the recording will be available shortly, as well as the slides. So I hope you all enjoy the rest of your evening. Thanks for joining.
Bye. Thank you, Ashley.